thing that they're shooting for, but probably a more likely realistic value for now to model against is to 156. Double. So I'm gonna change that because it's changed in the code as well. Okay, cool.
Yes, and this is for global aggregation.
This for global aggregation. So I've kept this part, like this is the end goal, really. Like local aggregation is I view it as the means to get to the end, which is this. Because ideally, if you were able to have a flat network and just aggregate once, that would be the ideal scenario. But because this is not viable, we'll need to introduce layers. So
it might be viable with GPUs, but yeah.
I mean, you still okay. So if you look at the raw, I doubt it, because if you do the very like simple multiplication of how much traffic this requires, it's like around 3 gig. If you're shooting for 1 million validators, right? So I think you are necessarily going to need to layer, and probably layer in more than one level. If you're shooting for that, right? If you're shooting for 16K, then that would be like 50 meg still, which is, probably okay in a setting where you know who you're sending to. And that node is fine paying for the ingress of that traffic, which is, I don't know if that is a viable scenario, but we can run the numbers and like figure out if that is potentially viable in the future. I don't know. Cool. And then the idea here is to distribute the result back to all validators before the next law begins, right? So you want validators to have the aggregate signature so that they can build or verify the right state transition next. Cool. So just a few numbers here that we can shoot for, and this is work in progress, but is this part that I haven't figured out yet. So let's say that we're shooting for, in this prototype, for 16K validators, 16K nodes, which is also the size of the consensus layer network today, like around the same magnitude, right? We assume that we have 32 global aggregators. Is that a fair number to assume?
Okay, sorry,
Yeah.
I just had a quick question before you ask that.
Yes.
You said that's the validator count, but you said it's 16K nodes. It's
Yeah.
not 16K validators. I think.
No, so I'm assuming a one-to-one mapping here.
Okay.
Yeah, so 16 validator nodes, 16 nodes, we can call this node count as well, if we prefer. But yeah, so I'm assuming a one-to-one correspondence here.
Basically, assigning validators. You could say.
Yeah, and the reason I'm doing this is because many validators behind a beacon node is a centralization vector. And kind of like one of the goals of Lean as well is to commoditize, the protocol so that even constrained devices can potentially participate. So I'm assuming the ideal scenario is you have one validator and one device. Assuming that. And modeling for that, right? If there is, for example, say 10 validators behind a node, then that node would have to transmit 3 times 10, right? Signatures. Maybe they can compress them in some way, but whatever. So is that good? Do we agree with this modeling for now? All of this is okay. Global aggregators, 32 global aggregators. Does that seem like a fair number to model against?
We did 100 in our simulations, but I don't know. We just picked it out of nowhere.
Yeah. So we can try. We can do different parameter sets as well, and. Like 64.
The question is whether they are permissionless or they should somehow be, registered, have some stake or anything.
So one thing that would be that, this is, I think we should have dynamic aggregators that are selected by the protocol, similar to the way that the beacon node behaves today, and simulate with that and use that as a baseline. So take the beacon, the beacon chain as a baseline, and kind of do what the beacon chain does today, and then we can start changing things from there.
Mm-hmm.
Sorry, what is a global aggregator versus a local aggregator?
So the idea is to use this same protocol in the 2 layers of aggregation. So for both global aggregates, and I'll go into this in a second, and also for kind of like the local aggregations in the subnet. Like if
Okay.
yeah.
Right. Okay.
The question for both kind of global and local aggregators is whether they are also validators or not. Well,
Yeah, it doesn't matter that much. Yeah.
Well, doesn't matter that much for now. Yeah.
Yeah.
Just for information, Justin said that
Yeah.
in theory they might run validators might run some kind of tests to prove that they are powerful enough to actually become aggregators, and then they also aggregate.
Yeah.
That was just some idea, but
Yeah. Which, for example, in Solana, in Alpenglow, they actually today apportion bandwidth share based on stake. So they require validators to have enough, to supply enough bandwidth capacity to the network in proportion to the stake. I don't know how they track this, but would be good, because I think it would be good to look into it, because I think they published their code recently, so we can look into how they do this.
So does the local aggregators are out of 256 validators in a single subnet? Do I understand correctly?
I would assume yes. Yeah. So basically, the idea is that if you're able to, just like today in the network, you assign validators to committees. What you can do is then give them the role of the aggregator as well, which is like very similar to what happens today in the beacon chain. It's like, if you look at the beacon chain, it's very similar. It's you have aggregators in a subnet, and then you have sync aggregates, which are global. Yeah. So it would be very similar to that. We also would be modeling against different subnet counts, I think, and this could be actually a proportion. Like this could be dynamic, and it could be a formula based on the validator count and like some desired target for local aggregators, for local nodes that we want to have in the subnet at each point in time. Yeah, and
Just a
then
quick question: do we need to record this?
It's recording.
Okay.
oh great! Hey, I didn't know I was being recorded. Great.
Oh yeah.
Surprise! It's being streamed live.
It's not streamed. It's not streamed.
Yeah.
It's recorded.
Big Brother is watching.
Yeah. Okay, cool. So then that would give us a subnet validator count of around 256, which seems like an interesting target to pick. Now, payload sizing. So modeling against the aggregate size, the raw size of 256, which is
Can I
the
comment before we went too far from that?
yeah.
Just for information, with subnet count of 64, as I said, the expected aggregation rate for snarks is 10 snarks per second. So that means
Right.
we have 64 snarks which we need to aggregate.
Yeah.
With 10 seconds per slot, with 10 snarks per second, it's like 6 seconds.
Yep.
So that's should be ideally it should be lower. But if you have GPUs, of course, we have different assumptions.
Snarks per second, 64 and viable. Let's just say that for now. Cool. And then, are we good on this block? Yeah. Cool. And then we have an aggregate. So let's move on to the next block. This is about payload sizing. So what we're actually going to send is an aggregate. The aggregate currently is a realistic size for it is 256. If we extended for erasure coding broadcast, erasure coded broadcast with read Solomon codes would be having twice the size. So really what we'd be transmitting is 512 kilobytes. Cool. Good there?
Yep.
Okay, cool. So now one network approach that we can take here is to split this payload into MTU sized chunks and use UDP to spray these chunks around within the subnet and at a global level.
Mm-hmm.
This is a very interesting, I really like this design avenue because it allows us to parallelize like basically all network paths, because you just have data that's disseminating. The important bit there is that it has to be authenticatable, right? Because like otherwise you could be open to just receiving garbage, and you don't know because it's erasure code. You don't know what to expect, right? So that's the important bit. A safe MTU. So this would be basically the. Are we all familiar with what MTU is? This is basically the network transmission like unit, which is. When you look at UDP, usually there is like you can just send a single frame. If you can send larger payloads, but that you have to build the framing and the chunking in your own, and then the retransmissions and so on in your own application protocol. So really, the best way to use UDP and quick datagrams is to just target MTU size, and we want to pick an MTU. So Quick actually dynamically discovers the MTU of every path. And like a safe value, because we want to pick a value that is static, because we're going to be designing our protocol against it, even though Quick calculates a runtime like a dynamic MTU for the path. We can't use that because not all paths are guaranteed to be same in the network, so we have to settle on some safe MTU, and that would be if we want to support IPv6, which we should. Absolutely should. it would be 1,280 bytes, which then would need to contain not just the chunk data, but also the framing around the chunk and enough contextual information to determine whether the chunk is valid before integrating it into the decoding matrix.
Sorry,
Yeah.
I just you want to be too fast. Like, why is IPv6 worse than IPv4 for this thing?
I have to look into the details of this. I'm not exactly sure why, but I think it's because of the extended, like the length of the IPv6 address takes up more space in the in the network fragment essentially, and like once you start looking at, so the values are different for TCP and UDP because they take up different, like they have different framings. Kind of like you start detracting, right? Subtracting, you end up with this, like that being a safe margin, a safe value for IPv6, the worst case scenario essentially, which is IPv6 with UDP, I think, and not TCP, and like some other variable there.
Okay.
Cool. So within that, we would need to fit the actual chunk data, but also the framing and the enveloping of the chunk, which would include a signature. I think this is like we're going into like a specific protocol design now. So this is kind of like the context, right? And now a specific schema here for this would be to have a signature where that is sent by the signature of the aggregator, essentially. So the aggregator signs over every chunk. So it's authenticated at origin. The network or the subnet and the network knows who the aggregators are, so they can validate that the chunk is coming from the right source. A potential attack vector here could be the aggregator could sign garbage and you wouldn't be able to decode. Is that slashable? Is that penalizable? I don't know if it's even worth it because, presumably the aggregator would be having some incentive to aggregate and they would forfeit on that incentive if their aggregate does not get integrated into the chain. So I don't know if this is the case, but I would assume it goes in that direction. So then we take the MTU and we start subtracting the signature size and some overhead that I'm reserving here just to account for some framing overhead, and we can go into what the framing could be. And that would give us a specific chunk count, which I think if we resolve for this, we do the ceiling division of the aggregate size over the raw size of the chunk, and that gives us around 432 chunks per slot, per aggregate in a slot.
Do we use BLS to sign a chunk?
Yeah, so this is one question I had for you guys. What are we using as a identity I guess, an authentication scheme here for validators identity.
I guess we cannot use XMSS because it's just one signature per slot.
For sure.
Yeah.
What do we need for? What do we expect for this signature scheme?
Can we use
Yeah.
p2p key for that?
Yeah.
If you can map the P2P identity to the aggregator identity as it's like mapped in the protocol, as it's registered, recorded in the protocol, then yes. I assume that the protocol is going to be tracking a public key. What is that public
But
key?
we don't. I thought one of the principles was that we don't want this mapping to exist.
Exactly. I don't think that's the right choice.
Yes. Okay.
But,
I think it should be the
Between
protocol
the node
key.
and the pub key.
Huh?
Between the node and the validator.
Exactly. Yeah.
Mm-hmm.
So the validator pub key is right now what scheme are we using? Except yeah. So it's okay, and it's only one-shot signatures that we can produce. Can we produce like one-shot signatures per one signature per chunk? Can we nest?
That would increase the size of the key, like not chunk size, number of chunk times. And the keys, they already pretty big, so we need to like, we can talk to Benedict. He's know better about that. But yeah, like we need to spend multiple days to produce enough keys for the I don't know, maybe 8 years. And now if we say that okay, we actually want to sign chunks, then
But is the aggregator signing, like if the aggregator is if aggregators are a subset of all validators, and the aggregator is not an attester in the same slot where they are
or they could be both attesters and aggregators.
for the same slot.
Why not?
Yeah, I mean today.
Yeah, today it is the case.
Right.
Yeah.
Right?
Yeah.
But like maybe there are reasons
I mean,
for this
it's-
not to be the case.
Yeah.
In the future.
It's not super improbable. It's not super probable, I think, that they are, but it could be the case. Yeah, the protocol doesn't prevent it.
I guess this was just to say that sort of
Yeah.
if sort of they don't attest and aggregate in the
Yeah.
same slot, like there's no dependency for the key size or key duration.
Yeah. Honestly, I don't
You
think.
could still only sign
Yeah.
once per slot.
Just to like iterate a little bit, I don't think we need post-quantum properties for this
Yes,
kind
we
of
don't.
authentication.
Right.
Because it's ephemeral, it's a message. Like what you care about is the end result. This is you're just authenticating data while it's in transit. So I don't think we need post-quantum properties for this, post-quantum security, but that would require still that a validator have two keys, one that is PQ and one that isn't. So for ephemeral operations like this, they would use and this would be recorded, both keys would be recorded in their entry in the protocol.
Okay, I think we can just put it as to do, maybe figure out what key to use.
Yeah.
For now it sounds like there should be a third key in addition to
Yeah.
the quantum key and p2p key.
Yeah. Yep. It could be that. Yeah. I mean, at that point, like if we can figure it out. For now, I think the problem with does the BL? I think like if we have a ephemeral key that we just use for network operations and it always remains constant, isn't it just like a pure like a networking public key? It's just equivalent in terms of behavior to a networking key, which then like maps to a peer ID and like so maybe this rotates. Like we need to figure out how we do this mapping in a way that it does not map back to a particular node in a network identity permanently. So maybe there's like some like key generation here, that scheme that we can use to cycle this key. I don't know.
Sign this key by ring signature key of validators.
Yeah, because the thing is, if you rotate, I mean, I assume, I don't even know if ELS lets you do some key derivation, which I think
Yeah.
it does.
Yeah.
But if you do that and you use a non-quantum secure sign,
Yeah.
ultimately you could go back to the previous, like to the actual owner
Mm.
and figure out who that is.
Mm. Yeah.
The other thing I was just thinking, can you, if you say those things are transient,
Yeah.
right? I guess this is why you want to rotate the keys.
Mm.
But because if you don't, you find yourself potentially someone with a quantum computer could eventually start signing messages and pretend to be you, even though they don't even need to know who you are. They could
No,
just
they cannot break the key that fast, even when quantum
I mean,
computer exists.
it's impossible right now, but
No, it's I mean
Yeah.
even when it's gonna be possible, it's gonna take not like 1 second or 2 seconds. It's like
Yeah, but still,
hours or
if
days.
you
right.
yeah, but you can reuse, like if you
Yeah.
know that the key does not change, then you can amortize that compute and use that
Yeah.
key. Like you do it once and then you can reuse that key as many
Yeah,
times
we
as
need
you
some
want.
data some cost.
If I
That
want-
yeah.
yeah. So we need to never reuse the keys. That's what I'm saying.
Hmm.
Otherwise, yeah, we.
Yeah.
But yeah, so maybe
Yeah.
maybe I missed that part. But did you want to use BLS in the final?
No,
design?
it's just a placeholder, honestly.
Okay.
Like we can use BLS for now for
Yeah.
the prototype and then figure out what we do with this.
But then
Yeah,
that's what
this
Camille was
identity.
saying yesterday. Can we just do like a signature by we just trust it to
Yeah.
be true? Because what we're
Yeah.
interested is
Yeah.
the network conditions. We're not really interested in.
Yeah, it so we can reserve, like if we don't want to do any signing, I think we should do the signing because it gives us a better understanding of the performance of a particular scheme, or we could just simulate that we
Yeah.
like spend some time signing or whatever. But also this becomes important for the sizing of the chunks, right? Because it's not the same to have like 300 chunks or to have 500 chunks. So understanding like the overhead, it could be a placeholder. Is important. Cool. Right, so for the scope, just kind of like to touch on scope, this protocol.
I
Yeah,
just had a
yeah.
question. When we split into chunks, do we have a thing that we need to also build some Merkle tree, assign Merkle root, then assign
No,
the
no,
groups,
so
because this would increase?
I've left this out of the equation.
Okay, okay.
So there's no proofs of any kind that we're emitting for the chunks because I'm assuming that we're authenticating them through a signature. And that's it. And we know who the aggregator is ahead of time. So we just verify incoming chunks by signature, and that's it.
Mhm.
Right. Yeah, so just to like continue, we would be using this protocol for the two use cases that we mentioned. So that would be for global aggregation broadcast and local aggregation broadcast. And these have different producers, right? So we have local aggregator producers and global aggregator producers, which right now are 32 each. So, pretty much the same from a producer standpoint. But for consumers, this is something I want to check with you guys, if this makes sense. So the critical path really is for global aggregators to receive the local aggregates. This is really the critical path, right? Cool.
Why?
Because local aggregators are interested in, like local nodes in the subnet would be interested in knowing if their signature has been included, but they can really not do anything about
Local aggregators or local validators again?
it. Local validators, sorry.
Uh-huh.
Yeah. So subnet validators would be interested in knowing if the signature has been included as soon as
Why
they
are they
can,
interested
but
in
like
that?
they can't really do anything about it if it hasn't.
I mean, do we care if they're interested or not? Eventually, they will see global snark and which proves supermajority of signatures.
It's
Yeah.
for rewards, right?
Hmm.
Like we reward that it is based on the inclusion of their
By the way, it's a question. Do we? Once we have a global snark,
Yeah.
does it have any? Maybe it has ZK properties which we actually don't want to have, so that we cannot map. Oh, does it just prove that the keys that were signed, or the keys they actually belong to the proper validators? I mean, the keys that we aggregated, they actually belong to the proper validators. Oh, we don't have this property. We need to ask crypto guys.
But we need to make sure like that the attestation has been included into a block, whether that's proven with the K or
Not the
that's-
attestation, but aggregation.
Yeah.
Yes.
No, but you were questioning like the
Yeah.
local validators.
So, I think like the local validators are still okay. So let's maybe move on very briefly to the global, and then we can switch
Yeah.
back to the local. So in the global aggregator, I think it's this one is very clear. There's going to be X, global aggregators producers, and the entire network is interested in consuming the aggregate,
Yes.
which includes the validators that were in the subnet, and this is how they know if their signature was ultimately included or not, because this is what counts. Right, the output of this.
And
So really the
just-
local, yeah.
Just curious, at which point are we making sure that if those local aggregators,
Yeah.
if two local aggregators connect the same attestation, that those are not counted twice? Then that means the global aggregator would have to detect that.
Whenever they create aggregation, they also sign maybe subnet ID, add to the message, they add to the message the subnet ID, and the global aggregators, they might have a rule which I was proposing that they only observe one local aggregation per subnet, and they can check it by this subnet ID. And then they ignore, once they receive the first local aggregation from particular subnet, then they ignore all other aggregations from this subnet. That was my proposal, but yeah.
Okay, just making sure this is covered.
So, can you repeat your
No,
question?
I mean, if I,
Yeah.
as a validator, would send two validation to two local aggregators.
Right.
That's a
Wait, you
are
sent
we-
an
Is-
attestation to two aggregators.
Yeah.
Yeah. Well, you actually. So this is something to figure out. Does the node send or does the node publish? Because the way it works today in the protocol is there is a topic, and aggregators are listening to that topic.
Yeah.
You don't know who they are, but they're listening to that topic. Everybody else receives the aggregation, receives every single attestation, and some of those consumers are
Okay.
aggregators. So then, so that is the push. That is the publish top sub model.
I see.
There is another model here, which is you alleviate the entire network from having to, or the subnet from having to serve as a forwarder, and you just, if you know who the aggregators are, you just send to them. It is more efficient, but it requires you knowing ahead of time who the aggregators, the IP addresses, and the endpoints of the aggregators. And this is the de-anonymization problem again.
And also this de-anonymization from the perspective of validators, because now we see who's from aggregators see who exactly sent the signatures.
But
Yeah.
you could also do something like Tor-like, where you could just have three hops and that's it.
Adding more
Yeah.
hops.
Yeah.
But that adds
We already have
latency.
too many of them because
Yeah.
somebody
But the problem is that it adds latency.
Sure. But what I mean is between the full gossip sub, where you don't know what I don't know what the average number of hops is.
Yeah.
But maybe 3 hops is actually much better.
Yeah.
And if we have that,
So one interesting idea there is to create a mini mixnet inside each subnet that is gated, is permissioned by presenting a proof of validator.
Right.
So you only allow validators to participate in that mixnet. You don't know who the validators are ahead of time.
Yeah.
You just know they're participating. You would need some association to know, if they are supposed to be participating in the subnet, which is where it becomes difficult because now you de-anonymize, right? But I like that solution space because it's Gossip Sub already has hops. So why not use those hops to anonymize by having some onion routing, for example, right? That's one possibility. Onion routing is probably not the idea. It's inviolable because it requires you knowing who you're sending to again.
Right.
But yeah, some form of maybe oblivious HTTP is a good example here, where they just have 2 hops. One that anonymizes the sender, one that decrypts the content, essentially, and then that would be delivered to a mesh of some kind. Yeah, that's maybe like another, but all of these solutions end up adding latency, right? And that
Right.
is the trade-off, the big trade-off. Yeah.
How do you avoid the liveness failure on the aggregator side if you have a direct, like if you have an expected relationship between the local and the
Well, you have redundancy, right? Because you have 32 aggregators. So if one of them fails, right, you would be having redundancy there. Is that what you're asking, or?
yeah, okay, so the aggregators subscribe or have to maintain a connection to all, or to like to multiple validate, no, to
Valid, yeah.
All validators in subnet.
Yes. They would, validators in subnet would connect to them and like in some way prove that they are a validator inside that subnet, inside that is associated with that subnet.
Yes.
Of course, there's like way too many, like in some form, like, you know, some open, like a lot of unknowns here of how that would happen. But I do think that like, even if you do the direct communication, over time you can de-anonymize validators. So you would need some form of like, I think, if you want to guarantee privacy and you want to guarantee, you want to avoid de-anonymization, then you would need to have like some form of oblivious routing there.
I was thinking about liveness, we have like local aggregators who everyone's connected to, so they send their signatures to them. But if we also have, like, for example, Gossip Sub, which we have today, and in addition to these aggregators, we also have, which I call them private validators. They do not actually say private aggregators. They do not say they are aggregators. They behave just like any other validator in Gossip Sub. But in fact, they are also aggregating. Nothing stops them. They're purely altruistic, and but that's more like a backup, just in case. If these aggregators, for example, we decide that we need to expose their address, and for some reason they become target for DDoS attack, well, then our network kind of becomes slower. But since we have these private validators that only participate in Gossip Sub, then they still can, they behave as a backup, so they create aggregation. That could be just one option. Introduce these private aggregators, but they will not be incentivized. Well, I think public aggregators also will not be, we cannot guarantee that they actually exist. So,
So this is more or less how the L1 works today, where you have the aggregator duty and they just are subscribed to the subnet because they're assigned by the protocol, and you just don't know who which node it is ahead of time. I think you might be saying that you don't even have a protocol assignment there, right? You just have altruistic.
Yeah, I mean, if validators need to observe all signatures anyway.
Yeah.
So maybe they can also, if they are altruistic, I don't know, they decide for whatever reason to also be aggregator.
Yeah, look,
they will be a bit slower because they do not really use the protocol that we trying to create for aggregators, but they exist there and more like a backup just in case we have some DDoS attack.
Yeah. So I think we should stay focused on this protocol because I think this is another rabbit. I think this is the complex piece, right? Of we haven't cracked it yet of how we're gonna be doing the individual attestation broadcast, and probably that should be a topic for we should continue working on. But in parallel to this, just one thing I would say is that might be a good reason to have validators also subscribe to their local aggregates, because over time they can score their inclusion probability as aggregators are selected in the subnet, right? So say for example, I consistently see over time that a particular aggregator fails to include my attestation. I know that like I will send my attestation anyway, but it should be the last validator I send it to. Like I should deprioritize that validator because it's consistently over time failed to include my attestation, for example. So that it creates a feedback loop, which I think is interesting that we might want to leverage. Yeah, that's. But you can maybe also get that information from the global aggregate, maybe not. I don't know, because yeah, it depends on how you send.
It's not really a lot of information, it's just bit fields
Yeah.
who created
Yeah.
the application.
Cool. So any other ideas, thoughts, or directions that might be before we move on, like before we go back to erasure coding? Huh? Okay, cool. So I was
just as a general comment, like it seems like the trade-off, like you're walking here is either like a completely like untrusted relationship among the complete validator set, like independent from validator, local aggregator, or like global aggregator, and sort of p2p efficiency, and sort of all the tricks, optimizations, like direct connections.
I mean, that's
sort of the.
That's always the dichotomy, right?
That's okay.
It's, yeah. I mean, if you look at, for example, Solana, like they rely on fully permissioned networks, and that's why they can optimize. They can they can make certain decisions at the networking level. Like for example, in Turbine, they have a every chunk has a deterministic propagation tree, and every node in that tree knows who they need to send to next, and how many peers, and like exactly the peers that they need to send to next. So of course you can play these tricks.
Right.
And
I guess just as a comment, I mean, we're optimizing this whole thing for like maximum uncorrelation. So the pq2-10, whatever logic, this is sort of the ultimate meme for uncorrelation. So it's like, like I don't know what it has to mean eventually, but just from like if you look at this from the above, it's like okay, if we then would have like direct connections, like super optimized, direct links, then like. Why do we even like worry about like this pq2-10 logic in the first place? Just as a comment, like I don't know
yeah. The trade-off is really you want the redundancy part of things and the censorship resistance, and you want the I think like in general the resilience of the network,
right.
When you don't rely on a single endpoint, right, or a single peer to like service a particular duty, but you can decide to like you can get the same property without using pub/sub necessarily, right?
Okay,
yeah. You can get so that would be like the thing to say. Okay, how can we get the best of both worlds essentially?
Right. Okay.
And there might I think like ultimately if we keep pushing the boundary for throughput and we keep like staying, enforcing these values, we're gonna need network breakthroughs. Like this is not gonna, like the traditional protocols are not gonna be enough.
I'm sorry to report it's already, we still have an hour, sorry. I thought,
there's another session?
No, it's just that we have the group
Debrief.
debrief at 5 and my computer is still in European time.
Yeah. European. Okay, cool. So just to like go into erasure coding itself.
Yeah.
Okay, so the idea is keep it simple for now. Just adopt read Solomon erasure coding, and the idea is to reuse the standard functions that we created for blob encoding. So there's no reason to reinvent the wheel here. There is a library, it is proven, it is audited, and it has binding in all languages. I don't know if in Zig, but definitely in Rust.
It is in C, so Zig
you can bind straight. Yeah.
I already have a Zig binding.
Nice.
But I wrote it a year ago.
Okay. Nice. Yeah, like predicted the need. Yeah, nice.
I have a couple questions for this. The first one is I'm not sure exactly how because I don't remember. I've seen the presentation about like this stuff maybe 3 years ago.
Yeah.
But there was a two-dimensional sign.
Yeah.
Are we going to do two-dimensional sign?
No, it's just 1D here. Yeah.
Okay, so one dimension, that's
Yeah.
cool. Except That means if we go in one dimension, but yeah, we should have enough. We just need to make sure we have enough elliptic curve points to do that.
Yeah, right. So this is basically what we adapt now.
Okay.
So these are like the thing is that the library has some statics there, so it has some constants that are pretty like specific to the blob use case,
Yeah.
which do not like match what we need. So we would need to fork the library and override those constants. Or like we can provide them as built parameters or something like that, and like just make change the library. It does like some of these actually specifically talk about blobs. So the name contains the word blob and cell, which are like very domain specific. But for now, I think for the prototype, just forking it is good enough.
Wait. Because what do you need? Is it small? This is smaller, right?
This is larger. Like
This is
where,
larger?
yeah, because in blobs we have 128 kilobyte blobs. Here we have double.
56.
And we're actually generating and sizing the cells to stay below MTU. So we no longer can use the same parameters because the library splits cells into 2 kilobytes.
Yeah, so the 38 number came from the say MPU.
Exactly. Yeah. So this is coming from basically. So we're using like 32 bytes is the scalar representation, right? And then like you multiply by 38 and you stay below MTU, or like way below, a little bit even below MTU, to leave space for the pattern, to leave space for the framing.
If it's larger,
Yeah.
then do we have enough? What's that called? Like powers of the secret to cover that thing?
If it's large, sorry, can you say that again?
Like I forgot all those names, but the idea of KCG is it's a polynomial you commit to, and
But we're not using KCG. We're not using the KCG part of this. Like it's a misnomer. This library is called KCG, but it also does the erasure coding. So we're not actually we do not generate or verify KCG cell proofs because we don't do a commitment because because this is just for networking. It's not. So a commitment is necessary because we commit the blobs to a block, right? In this case, this is just ephemeral, like in transit, erasure coding to move the data around.
Right.
And for that, we just need source authentication.
Okay.
Yeah.
So we don't need to do any sort of ceremony.
No. No.
Exactly. Yeah.
It's just erasure coding.
It's just erasure coding. It's a misnomer. The library is called KCG, but if you look at it, and actually the methods, the functions themselves are recover and prove, or like they already involve proving, but then if you pass null values to the specific fields, it will disable, it will not do any proving. So it's kind of like, well, I mean, this makes sense because like when you build a library, a C library that is gonna be exposed through FFI, you wanna minimize the FFI overhead, so you just like really overfit the library to how it's gonna be used, which makes sense. But for us, we don't need a big portion of this. So eventually we'll have to, like if we decide to commit to this direction, we will have to build fork this library and actually make it smaller and like adapt the parameters and everything.
I think that's the first action item for the Devnet one, so we need to create this simplified library.
Yeah, and this could be done very quickly. So
Yeah,
because it's just overriding
it's not
parameters.
implementing something new, just simplifying.
Exactly. Yeah.
existing thing.
Cool.
So just jumping back to the fact we're not using actual KZG stuff, we don't need to worry about quantum resistance, right? The Squid Solomon code would work, right? Because otherwise Fry would not be quantum resistant.
Yeah, I think it's orthogonal because it's also just in transit. The chunks are not going to be persisted in the protocol in any way.
Right.
Yeah. So one thing is like something that I hated was that this was not binary aligned, but I don't think it's gonna cause any problems because of the way that it's not gonna penalize performance, because I don't think that this would affect CPU caches or memory or anything like that, but we should benchmark against different values anyway in case we prefer. We see there's a significant gap there, then we might prefer to use other parameters and lose some edge on the networking side of things if it's justified. Cool. So this is like where I kind of stopped a little bit, but like maybe we can think about this together, and I can continue working on the framing. So what I try to capture here is what would a packet look like on the network, right? So I think we will be having a chunk slot number. We would be having a chunk index. We'll be having the chunk data and then a frame signature. So a signature for over these three fields that is produced by the aggregator. Sorry, this is a bit messy. It was just like halfway through. So do we think that we need any other value here?
Right, index.
Quick question, like,
Yeah.
what are we erasure coding? What is the object again?
The aggregator signature. The aggregate signature.
In future, it could be also the block itself.
That's not.
Not could be, it should be. Yeah.
It could, yeah.
So we have
Yeah, but that's
one-
like something that erasure coded to block propagation is something that we're doing already in the L1. It's gonna, like, we're already
I mean
investigating.
block. You said
For the block
or
propagation.
You mean for block propagation we're already using erasure coding?
No, we're looking into it.
Looking, yes.
Yeah, so I don't think that lean would need to look into it specifically as well. We'll be duplicating work.
Yeah.
So the framing, is it important to know which validator in the protocol did the aggregation or no? If not, then we don't need to validate next week.
Right. So depends on whether you can recover from the signature. You can recover their identity from the signature. You might just be able to recover it, because like what's going to happen here as well, and this is something that we should probably talk about, is that there's going to be competing aggregates in the network,
Cool.
right? So at a global level, it's possible that you'll be having different aggregators produce different snarks because they collected different numbers of quantities of local aggregates.
We use this erasure coding on only for global or for local aggregators as well. Aggregations.
We use it for both.
We want to use it for both.
Yes. Now, something that we could do is each chunk could also carry a commitment to the whole payload, and therefore, if you have matching hashes or commitments, so this is maybe where the KCG commitment would become like interesting, or maybe just like a hash is good enough because you don't need to like prove every chunk, maybe, I don't know. What you can do is like create many lanes as you receive these chunks, and they are coming from up to 32 aggregators. Imagine that like 31 of those aggregators arrive to the same aggregation result, and just only one of them arrive to a different one because they missed maybe a local snark, right? Then you could actually you could combine and reuse the chunk data inside those, like no matter which of those 31 aggregators you're receiving it from, because they actually arrive to the same result.
This is impossible. They will arrive to the same result.
Okay.
Because we have like subnets.
Yeah.
For example, 1,000 nodes in the subnet, let's say in the future.
Yeah.
And each aggregator, they will not wait like 100% of signatures to be received before they start aggregating. Because if this is the case, then we have one slow or malicious validator who is not producing the signature, and then we're stuck and we never come up with aggregation. So we should create some kind of threshold, like for example 90% of signatures that we want that each aggregator is waiting for before it starts aggregating, and each aggregator more likely than not will receive different set of 90% of signatures.
Yeah, before so right now, just to like back up, I was talking about global aggregates.
Okay.
Yeah, where I think it's way different because you do have more likelihood that you'll be having overlap there, because the data that you need to receive is only 256 kilobytes per subnet, and you'll be having a limited number of subnets, right? So if you have 64, like what did I define? 64, 120, or what did I go with? 64, right? So you have 64 times 256 times 2, well, 256 because this is what you need. You just need to receive 16 megabytes of aggregates, right? If you're assuming that you're going to be receiving all aggregates from all subnets before you actually go and produce the global aggregate. So I think that's like the domain is way smaller than with local aggregates and subnets, right? So I do think there's a high likelihood that we can parallelize and like actually reuse the aggregates between global aggregators, way less in local aggregators, because that is 3 kilobytes over like 500.
The use is, for example, some global aggregator, let's say we have for simplicity just 8 subnets, and some global aggregator, for example, already aggregated subnets from 1 to 4,
Yeah.
and another aggregator aggregated from 5 to 8. And then you mean, this is what you mean by
Oh, no. So I would assume that global aggregators
Yes.
are attempting to aggregate all of them,
Yes.
right? So if I have 8 subnets,
Yes.
then, and I've received all 8,
Yes.
and I have 32 global aggregators, and only one of them has not received, like say subnet 7,
Mhm.
right? Then, which is the last one, right? Starting from 0 indexed. So they have 7 subnets, and 31 aggregators are aggregating 8 subnets.
Mhm.
The chunks of that those aggregators are going to be publishing should be reusable because they're aggregating the same data. They're arriving to the same result, right?
Mhm. Okay. Yeah, they will be
Yeah.
reusable
Yeah.
because the parity data in the repository is
Yeah.
not changed.
The problem is that with this schema, you don't know ahead of time, right? So maybe we should add a commitment to the aggregate. And maybe not even to every chunk, maybe to like even or odd chunks to amortize. So you just really need one chunk from a given validator, from a given aggregator, if you can recover their identity from the signature, to map which hash, like which aggregate they're actually publishing. So you don't need this, or you can intersperse it in the data itself. Like you don't need every chunk to carry the commitment, because using probability, you're gonna receive like X number of chunks. Like say you receive 10% of chunks from in time of every aggregator, you can just like intersperse it.
Right, you mean interpolate?
Yeah. Well, yeah.
I mean, okay, you can recover. Okay.
Yeah.
Yeah. Okay. This way you can.
Wait, not really interpolate. Like we could do a simple thing here, which is you just publish every module. Like you put the commitment every modular chunks. But yeah, but that gives you like, what do you use the remaining payload for? Because you need a fixed schema. You don't like variable schema suck. So yeah, maybe we just commit it on every chunk, or we do the interpolation. We just like put it in the chunk data somehow, like stenographically. I don't know.
Right.
What do you think?
Yeah, but how do you hide something in the repo?
Yeah.
In an open.
No, I don't know if. Yeah.
Just one clarifying question.
Yeah.
When you say payload, you mean the CL block?
No, we're talking about aggregates here. We're talking about signature aggregates.
Right. That's sort of when we talk about the. Yeah. Okay. But so payload for you is you use it synonymous as synonym for
Yeah.
for
It's, yeah, I mean, in networking terms, it's like the data that you're gonna carry, which in this case is the aggregate, the signature aggregate, which is what this protocol is for. It's just for aggregates.
okay, right, because we have the term payload, like we use it.
Execution payload?
Yeah, for
Yeah, right, I know, yeah.
Okay. So payload is here only meant to refer to the
Yeah,
the
yeah,
networking
yeah.
power.
Yeah.
okay.
Yeah.
So the chunk is the chunk of the aggregate.
Yeah.
And then I do have one question as well.
Yeah.
So you mentioned that you mentioned about the commitment, right? And
Yeah.
that's for the hot path between local aggregators to global aggregator.
Mm-hmm.
But does that mean that if you want to have that consistent schema, does that mean that local aggregators also have to commit?
Yeah, I mean, to the global aggregators, I think so. Yeah, they would have to commit. It would be useful for them to commit. I think so, because that way the global aggregators can use the same technique, right, of leaning and reusing. Maybe not. Like, I think this is something we'll need to test, and it will depend on parameters. As Camille was saying, is like it's way more likely if you have like 500 validators in a subnet and just missing one signature, just having like a one signature diff is going to produce a different aggregate, then there's very low potential for reuse across the aggregates that all the aggregators within a subnet are going to produce. So maybe we omit it in that case, because we already know ahead of time it's like the potential for reuse is very low.
So I suppose like we follow the same schema, but then we don't have to
Yeah.
do that.
We just make it an optional field or something. But then the problem, there might be like two different flavors of this protocol, because the parameters will be different, right? Because if you want to maximize and pack as much data as you can inside the MTU, and you know that you're always going to not have this field, then you can pack more data inside and reduce the number of chunks. So it would probably be two parameterizations of the same protocol. Yeah.